Okay, if you look closely, this is going to look an awful lot like algebra. And I will tell you that from my experiences teaching geometry, this is a section that most of my students struggle with because of we are talking about equations of a line, the slope formula, and sometimes we didn't pick these things up in algebra, so we struggle with them now when we move into geometry. So bear with me. We're going to move through this, and I'll show you some examples, but definitely looks a little bit algebra-esque. So let's see here, some flashbacks or what we're going to talk about. We are going to classify lines if they're parallel, perpendicular, or neither. What do we know up until now? That we know that parallel lines travel and never intersect. We know that perpendicular lines intersect at 90 degrees. And then neither, well, I guess that would be anything in between those two things. And then we're going to learn how to classify them based on their equations. So looking at the slope and then being able to plug them into our equations. So remembering slope is the ratio of the change of the y over the x values. So the often called the rise over the run, it's a ratio. Slope is historically written with the letter m, and then we are talking about it is the ratio, which is nothing more than a fraction of the rise over the run, which means how far do we go up and down over how far do we go left or right. Often in higher level math, you will look at the change in y over the change in x, which is delta y, delta x. Nothing more than delta means the change. So looking at slope criteria outlines the method for proving the relationship between the lines based on the comparison. And let's see here, slopes. Slopes of parallel lines. Two distinct non-vertical lines have a same slope, if and only if they are parallel. So again, we know that two lines that are parallel, they do not intersect. Therefore, if they do not intersect, it would make sense that their slope is going to be the same, or the angle which they travel is going to be the same. And then perpendicular slopes. Perpendicular slopes will be, when we multiply them together, they will give us a product of -1. So what does that mean? Well, parallel slopes. If I have a slope of 3, then that would be parallel, right, the parallel symbol, to another line that has a slope of 3 because they have the same slope. And 3 is also written as 3 over 1. So there's my rise over run. And then perpendicular slopes. Perpendicular slopes look something along the lines of this. If my slope of one line is 3, it would be perpendicular to another slope which is equal to -1/3. Now, what they're talking about here is the product of the slopes will be -1. So when I multiply 3 times -1, 3 times 1/3, that is going to be equal to -1. If the product of the two slopes is -1, then you have perpendicular slopes. So you either have the same slope, you have perpendicular slopes, or you have neither, which is anything else. So looking here, so determining the line relations given the points. Now what I've tried to do here is, I've tried to go ahead and plot some points to help us out here, but determine whether line A, B, and line CD are parallel, perpendicular, or neither. And then they've given us the points, right? And I plotted them over here. Hope they're right. And it says graph each line to verify your answer. Okay, well, the first thing they did is they turned around and said, AB, this would be x2, y2, x1, y1. So here's my slope formula. So they substituted those in. So y2 minus y1, so 6 minus 2. And then you have x2, which is 3 minus, and then x1 was negative 9. So this would become negative times a negative is a positive. So that's how we have 4 over 12, which is going to be 1/3. The CD, they did the same thing. It looks like this is going to be x2, y2, x1, y1, and they plugged it into our formula, and they came up with, looks like this would be 4 minus 3 is going to be 1 over 5 minus 2, which is going to be 3. So 1/3. Now, looking at that, it seems to be that the two slopes are the same, so the two lines have the same slope, so they are going to be parallel. And if I were to graph that, graphing it may not be quite as evident as that. So if I graph my points here, I have line AB over line CD, and what we have, it's just a little bit more challenging to see sometimes based on your graph and how we plot points. Sometimes we can be a little bit off, but our mathematics tell us that that is correct. Let's see, let's look at some of these points and make sure they're even right, huh? Looks like A is, looks like that would be 1, 2, 3, 6. B would be -9, which is actually right here. So we're a little bit off right there. And then C, let's see here, C is going to be 5, 4, that looks good, and D is going to be 1, 2, 3. So D is actually right there. So I have plotted some incorrect points, and then that would look something like that. Okay, so yeah, it looked like I plotted my points incorrectly, but now that I've straightened them up, definitely they appear to be parallel. All right, so here doing the same thing. Hopefully I've done a little bit better job plotting these points for us. You know, nothing like something making mistakes like that. So here, AB, right here, AB, and then CD. Let's check our points. Looks like A is 14, 13. That looks good. B is going to be -11 up 0. Okay. C is going to be -3, 1, 2, 3, and up 7. And then D is going to be -4, -5. So I did a little bit better job here graphing. So if I were to connect CD, if I were to connect AB, it definitely looks like neither. Does not look parallel, does not look like they intersect at a 90-degree angle. Can I check that? Yeah, it said make that determination and then graph to verify my answer. So I will do x2, y2, x1, y1, and I'll do x2, y2, x2. I'm going to have an x1 and a y1. So I'm going to verify 2, and then I'm going to verify AB, then I'm going to verify CD using my y2 minus y1 over x2 minus x1 is my slope formula. So AB. Okay, so when you go to verify that, I take and I plugged the points A and B into my formula, and I came up with 13 over 25. So the slope of line AB is 13 over 25. When I did the same thing for C, the slope of CD is going to be 12 over 1. And then in doing so, remember, you could check it. Obviously, they do not match, right? They do not match. But when I multiply them together, I get 156 over 25, which does not equal -1. So then I know that they're not perpendicular either. Not parallel, do not match. Not perpendicular because they do not, the product is not -1. So that is how we verify the answers. That's how we check the answers, make a determination. So with that, moving forward here, determining line relations when the graph is given. Again, here's some examples real quick before we move on. Parallel lines have the same slope. Perpendicular lines have opposite reciprocals, because when I multiply these two things together, it's going to be -1. Opposite reciprocals. Opposite meaning one is positive, one is negative. Reciprocals meaning that my fractions are inversed. So with this, determining this, I take my points, right? I have point T and point U is one line, point S and point R is the other line, and they use my slope formula here, and they plugged in some numbers, and they said, uh-oh, these two things are not the same. We may have had to simplify our fractions as we move, but 10 over 14 is not the same as -6 over 4, so I know that they are not parallel. And then when I simplify the two fractions, if I multiply them together, and they do that here, this would be multiplying these. Remember, you multiply straight across, so 15 over 14, and there's a negative there, so it would be -15 over 14. That does not equal -1, so therefore they are not perpendicular either. So they fall into the neither category. Neither, neither, whichever one you choose. They are neither parallel nor perpendicular. When you look at EG here on this next example, they did the same thing. They plugged in our points, and if it's not as quickly evident, this is going to be x2, y2. So that makes this x1, y1. I got that backwards. See here, this is going to be x1, y1, and then this is going to be x2, y2, and then when I reverse this, this is going to be x1, y1, x2, y2, when they plugged them into our formulas over here. So when you simplify, we have -1 minus 6 is going to be a -7 over over 6 minus 3, which is going to be 3. And then you simplify the top, we have 6 over 14. Now, if you have difficulty simplifying fractions, you can see here that they're not the same, right? They're not the same because they're opposite signs. But if I were to multiply them together right now, I would get -7 over 3 times 6 over 14, which would become -42 over 42, which is -1. Or if you simply put this into the calculator, it would give you -1. So if you have difficulty with fractions, you can stop here and just multiply that in the calculator to get -1. Otherwise, you can see that you can simplify these fractions because both are divisible by 2. Both the numerator and the denominator are divisible by 2. So that would become 3 over 7. And now I can see negative, positive, that's opposite, 7 over 3, 3 over 7. Those are my reciprocals. So different ways to try to resolve your answer given your skills. Determine the relations, if any, between the lines. The two lines do not have the same slope, so they aren't parallel, right? Not parallel. And to determine whether the lines are perpendicular, find the products. And we just did up there. Again, -7 over 3 times 3 over 7 is going to be equal to -1. And then therefore they are perpendicular. And I'm using the upside down T or the perpendicular symbol. So here, determine whether, in this check, we'll just keep going, determine whether these two lines are parallel, perpendicular, or neither. And I would say, some things that we have to say is like, this is a horizontal line, and this is a vertical line. And if I were to, I'm going to do the slope formula here. I'm going to just count my slope. So the slope of line AB is going to be, again, the rise over my run. So I never, as I'm traveling down that line, I never go up. So my rise is 0, but my 1 is, my run I can just say is 1. Okay. And then the other one if I look at CD, the rise here is the slope is of CD is going to be equal to the rise over the run. The rise over the, goodness gracious, the rise over the run, and we rise 1, but we go over 0. So what I can see is that this is actually equal to 0. This is undefined. And we learned that all vertical lines, right here, all vertical lines are going to be undefined. All horizontal lines will have a slope of 0, and horizontal and vertical lines are perpendicular to each other. And if you think about it, my x and y axis are a horizontal and vertical line intersecting at 90 degrees, which makes them perpendicular to each other. So that's just something to consider. All AB, all horizontal lines have a slope of 0. They go up none, they go over. All vertical lines have a undefined slope, because you can't have 0 in the denominator, because that is an incalculable large number. So there you go. We move on, talking about those equations of a line now. Now that we've talked about how to determine if something is parallel or perpendicular, we can use our equations of a line to make those kinds of determinations. So hopefully, again, this hopefully is a review. Equations of a line. This is my slope-intercept form, probably the one that you started using possibly as early as 7th grade, if not earlier. Y equals mx plus b, where the m is my slope, the b is considered my y-intercept. So when I see it into an equation of a line here, y equals mx plus b, so my slope is 3, because that is the number, the coefficient to my x, and then my constant is plus 8, so that would be my intercept, my y-intercept. Where it intercepts the y-axis is 8. So being able to do that interpretation. And then point slope, often neglected. Y minus y1 equals slope m times x minus x1. So the things that change in this formula, again, so we have y equals mx plus some intercept number. For point slope, we have y minus my y value, whatever that is, and then my slope times x minus, and those are the 3 items that we would change in the point slope. So we have a point of x3, y5, a slope of -2, and we just plugged them into those missing things. Okay, so that's how we determine or differentiate or use our slope-intercept form or our point slope form. So with that, here they're talking about horizontal and vertical lines. Again, y equals are going to be my horizontal lines. Y equals, that is my horizontal line right there. Because no matter where I'm at on the line, no matter where, the x value is going to change, but y is always going to be -3. Here, -3. Here, -3, you know. So that's why we just say y is equal to, in this case, it would be -3. So like, for example, this point right here, that point right there is going to be -4, -3. Over here, that is 0, -3. Over here, guess what that is? That is 4, -3. My y values are never changing, so that's why we say y equals -3. Your horizontal lines, your vertical lines right here, those are going to be x equals, because again, no matter where I'm at on this line, the y values keep changing, but my x value is always going to be -2, because that's where I cross over the x-axis. So this would be x equals -2. So there you go. And understanding, and also, as I stated earlier, that any x lines, x equals 3. Okay, that would be this. Right there. X equals 3. x equals 3. And all of my vertical lines are parallel. They have the same slope. If I turned around and plugged in another line and I said y equals, we'll go with 1. Right here, this is y equals 1. And then that horizontal line would be parallel to my other horizontal line. So being able to work with that. Here, determining line relations given the equations. Again, being able to absorb the things that need to be changed. And I brought these over from the previous page in case there's any questions. So when I'm looking at these, and this, determine whether each pair of lines are parallel, perpendicular, and either. If I look at this real quick, I should know that, again, the slope is that number in front of my x, or that number in front of my parentheses for point slope form. So I can take those two numbers, the two lines blank. Do they have the same slope? They do not. They do not have the same slope looking at them. So the lines are, they are not, looks like a mott. They are not parallel. To determine whether the lines are perpendicular, you find the product of the two slopes. So the product, we have 3 times negative 1/3. That is going to be equal to negative 1. So since the product of the slopes is negative 1, the two lines are going to be perpendicular. So being able to look at the equation, understanding what's going on, and making those determinations. In this next example, if you notice, we have, this is going to be my horizontal line, this is going to be my vertical line, and we did say before that all horizontal and vertical lines are perpendicular, so we could just simply say, hey, we know that horizontal lines and vertical lines are perpendicular. And they did identify this horizontal line has a slope of 0, my vertical line has a undefined slope. And let's see here in this next example, they've given us some equations and they've identified it here, but I see point slope form. This is point slope form, and I know that my slope is right there in my equation. I know that for slope intercept, my slope is right there. And those two are the same, so because the slopes because the slopes of both lines are the same, the lines are parallel. And let's see this next example, D. Let's see again, here's this slope in point slope form. Here's this slope in, this is slope intercept form. This is point slope form. And they've identified it again here just in our image. And are the slopes the same? The slopes are not. Okay, they are not the same, so the lines are not parallel. Easy enough. Now, in order to determine are they perpendicular, some people make a jump real quick and they say, man, they're reciprocals, they're perpendicular. That is not true here. They have to be the opposite sign. If we multiply 2 times 1/2, we only get 1, not negative 1. So the product of the slopes is not negative 1. So the two lines are not perpendicular, and so the lines are not, we'll just say, not parallel nor perpendicular. So just being able to do that. Oh, here's 2 easy ones right here. X equals X equals. Those are 2 vertical lines, and we know that both lines are vertical with the same slope. With the same slope. And then vertical lines are always parallel. So again, not a lot of math here sometimes, as long as you're able to apply what we know and understand and moving into that algebra / geometry, moving back and forth. So here we have determine whether each pair of lines are parallel, perpendicular, or neither. Again, being able to use my equations of a line. I have a slope intercept form, y equals mx plus b, and I have point slope form, which is y minus y1 is equal to m, or slope times x minus x1. So making that determination. All right, so looking at those real quick, I can see that this slope is 3, this slope is negative 1/3. They're not the same slope, so they're not parallel, but if I multiply them together, I have -1, not a very nice one, -1, so that would mean they are perpendicular. In the next one, I have 9/7 over 9/7. It's a fraction, it's the same fraction, therefore those two lines are parallel. And then here I have what would appear to be two vertical lines. They have the same slope, so those two are perpendicular. So there you go. Being able to apply that. Looking at this word problem, Lord help us. Valentina is designing a park using grid paper, and she wants to build a sidewalk that connects with the fountain at P, okay, right here. We're trying to connect there. And is perpendicular to the existing sidewalk that passes through points Q, -6, -2, and R, 0, -6. Graph the line that represents the new sidewalk. All right. So it says here, graph the existing sidewalk, and they've done that, right? We see that right here. We have come up with a slope of -4/6, which is actually -2/3. And then in order to figure out what is my missing slope, again, opposite reciprocals, I will just say, hey, they said opposite would be a positive number, reciprocal would be, instead of 2/3, it would be 3/2. So there you go. That's one way to do it. We can now figure out that that would be -1. So the slope of the line that's going to be perpendicular is going to have a slope of 3/2. Okay. Now let's see. Graph a line that represents the new sidewalk. Well, I'm going to do this the easy way. Thinking about it, if I want to go through that fountain, which I erroneously bubbled in the wrong place, if we start right here, and we want to have that perpendicular slope, we just said the slope should be 3/2. Well, remember, 3/2 is also equal to -3/2, because negative times a negative will become a positive, so I can go either two positives or two negatives in this case. So if I were to graph that, if I were to start here and I go down 1, 2, 3, and then I go left, which is also -1, 2, I'm going to pass right through that point. If I continue doing that, rise over run, down 1, 2, 3, and left 1, 2. Those are the points that I'm going to intersect when I'm graphing this line. So I would have a slope of, that's what my perpendicular line is going to look like. Okay. And I can now have a good idea what's going on there. And again, if I did 0, 1, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and that's what it would look like on that smaller graph. And that's what they're telling us to do right here. Move up 3 units and then right 3 units. Plot the second point. Up 3 units, right 3, 1, 2. And we had to adapt here because, of course, these points, this grid is on a grid of 1. Every mark is 1 value, right? On this one, though, they started counting by 2, so that's why the graph looks a little bit different number-wise, but you think the general shape is going to be the same. So you have to keep that in mind. And then we know this intersects at a 90-degree angle. So graph the line. Didn't ask us to write the equational line, asked us to graph the line. And then finally here, Here's a quick word problem for you. Isabella's creating a map of her town's metro lines. She knows that line A and E are parallel. Okay, so these guys got the same slope. On her map, the equation that represents line A is right here, and E line passes through 9, 5. Okay, so I know that the slope is going to be 8, okay, for line E because they're parallel. Write the equation in slope-intercept form that represents line E. Okay, line E, if I take this point right there, that is going to be on my graph 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So that point is 9, 5. So I have a point 9, 5, and I know that my slope is equal to 8. So if I use point slope form here, y minus y1 is equal to slope times x minus x1. Plug in my values. This is my x1, this is my y1. So y minus 5 is equal to 8 times x minus 9. So do my inverse. I'm going to go ahead and simplify this now because in order to get to slope-intercept form, it has to be y equals. So let's do my distributive property first. I have 8 times x, and then minus 8 times 9 is 72. Y minus 5 over here. Let me go ahead and add 5 to both sides. And then y is equal to 8x minus 67. So that is the equation of the line in slope-intercept form. So since they gave me a point, they gave me a slope, I went from point slope form over to slope-intercept form because it was easier for me. And they're going to show us a different method down here below us, but I do know again that this would be my y-intercept because that's my equation of a line in slope-intercept form, and that's what I get out of that is the slope and the y-intercept. So here, this is just a different method of doing what I just did up there. They said write equations of parallel and perpendicular lines. So write an equation in slope-intercept form for the line parallel to this that contains this point. So it's passing through that point. We know here that the slope is negative 3/4. So we know that a line that passes through that, or that is parallel to that, is going to go through negative 3/4. So what they did was they said, okay, let's take the information, and they started off in slope-intercept form. And they said slope, my y value is x. They took that right out of the point. There's my slope formula. Then they said my x value, instead of having x, they plugged that in. And now they're going to solve for the slope, the y-intercept. They combined like terms. And then here they subtracted 9/4 from both sides. When they multiply that together, let's see, what is that going to be? I hate doing math in public. All right, so when they did that, they said, okay, when I multiply fractions, remember 6 times, oops, I just multiplied. Let me redo this. That's what happens when you don't show all your work. So here, so I subtracted 9/4 from both sides. 6 minus 9/4. The old school way is in order to minus 6/1 minus 9/4, in order to subtract fractions, you have to have the common denominator. So a common denominator between 1 and 4 is going to be 4. So if I multiply 1 times 4, I have to multiply the 6 times 4. So I have 24/4. Minus 9/4, which would be 24 minus 9 is 15/4. So the equation of that line is going to be negative y equals negative 3/4 x plus 15/4. That's one way to do it. That's how they want to do it. Me, I'm going to use that point slope form just like I did up there, and I'm going to, right here, I plugged in my slope, I plugged in my 2 points, and I'm going to now distribute. So I have y minus 6 is equal to negative 3/4 x. This is a positive, so that would become minus, I need to add these two things together, right? So, I'm sorry, multiply these two things together, which is, I'll just put it here so we see it. 3/4 times 3, so that is minus negative 3/4 x minus 9/4 equals y minus 6, add 6 to both sides, and then y is equal to negative 3/4 x plus, and then there's that 15 over 4. So again, two different ways to come up with the answer. I happen to like going from point slope form into the slope intercept form. For me, it's just a little bit easier. And then here, doing this example, final check here, do the same thing here. Write an equation in slope intercept form that is parallel to this point. And I did the same thing that I like to do, where I took and I said, here's my slope, 1/2, here's my 2 points. So I have y1 is 1, x1 is 3/2, so 1 minus 1, y minus 1 equals 1/2 the slope times x minus 3/2. Distributed my 1/2, so I have 1/2 x minus 1/2 times negative 3/2 is going to be negative 3/4. Added both 1 to both sides, so y is equal to 1/2 x plus 1/4, right? $1 minus 3/4 is going to be 1/4. So that is how I could come up with that answer. So again, this unit is very algebra-esque. Got to remember these equations, do a little bit inverse operations, but it is definitely achievable by everybody.